Hello, welcome everyone. Welcome, and you're joining SFU's Café Scientifique tonight. My name is Cynthia Henson, and I'm happy that you're joining us tonight. At this point, we are just waiting for people to trickle into the attendee room. Thank you so much for joining us so promptly at 5. I see lots of familiar names. Thank you to all those who keep joining us each time we do this, and a warm hello and welcome to all those joining us for the first time. We'll just give it a half a minute or a minute or so to wait for more people to come in. Again, this is Simon Fraser University's Café Scientifique. Hello to all those joining us from beyond BC. We keep ourselves on Zoom to welcome those both far and near who would like to join us. So thank you for joining us tonight. We also have a lot of colleagues from SFU. Thank you so much, friends, for joining us. This is our first Café Scientifique session for the fall term, and I'm happy that you're with us tonight. So thank you. All right, I have 5:02 on my time, and we better get started with this session because I'm sure you're all excited. So again, thank you for joining us. My name is Cynthia Henson, and I work at SFU's Dean of Science office, and I look after the outreach and engagement program on behalf of the faculty. Café Scientifique is a discussion series where we feature various faculty presenters to talk about their research. And this is the first session for the fall term, and we're happy that you're joining us tonight. We hold at least 6 or 7 sessions a year, and we're keeping ourselves virtual for now, as I said, to welcome those both far and near who'd like to join us for these discussions. After tonight's event, I will be sending out a feedback web survey. We're happy to hear from you, and if you have any comments or suggestions about this series, we hope that you could provide that on that web survey. And also, because you have registered to this event, your emails will be included in our Café Scientifique mailing list. So you should be receiving updates on the next faculty event. So thank you for that. I'm happy to see a lot of our regulars, familiar names. Thank you for always joining us since each time we do this, and a warm welcome to all those joining us for the first time. It's great to see lots of our community partners join us, even from beyond BC. Let me begin by acknowledging that we're privileged to gather today on the unceded traditional territories of the Squamish, Tsleil-Waututh, Coquitlam, and Musqueam peoples. We thank them for having cared for these lands and waters since time out of mind, and look forward to working with them in partnership as we continue to build this great city together. If you know whose territory you're currently on, please take a moment to reflect on this. And if you don't know whose land you're on, I encourage you to look it up and make yourself familiar with the Indigenous peoples whose land you occupy. A few house rules before I pass it on to our presenter for tonight. There is a Q&A box that you have access to. Please use that Q&A box to type in any questions or comments you have for our speaker. We will try our very best to read out everyone's questions after the presentation. The chat page is turned off just to simplify the use of the Q&A box. The live transcript is on. You can turn that on if you find that helpful. And just a reminder to all, this event is being recorded and the recording will be shared broadly on the Faculty of Science YouTube channel after tonight's event. Feel free to review it on that site. All right, so at this point, I'd like to take a moment to introduce our speaker for tonight. I'm very happy that he accepted our invite and he agreed to present at a Café Scientifique fall session. Tonight, we have Dr. Vance Williams, professor of our SFU's Department of Chemistry and also our Associate Dean for Graduate Studies. And tonight's presentation is entitled The Unnatural Beauty, Art, Science, and Technology. While art is often described in opposition to science and technology, in reality, these disciplines are mutually supporting and reinforcing explorations of the natural and constructed world. In this presentation, Vance will examine the intersection of art and science and the often blurry distinction between the scientist and the artist. So let me turn over the floor now to Vance and invite him to screen share his presentation. Good evening, Vance.
Good evening. Thanks, Cynthia. And thank you for all of you coming here tonight. I think this is the biggest crowd of people who've ever voluntarily agreed to listen to me talk. Quite a few students have come, but I don't know if they really wanted to be there. So I'm going to start off tonight by having just a few questions for all of you, just so I get the chance to get to know a little bit about all of you and some of your ideas. And so I'll be using Slido. So for those of you who haven't used Slido before, it's fairly straightforward. There's a QR code in the upper left-hand corner of the screen. So the easiest thing to do to access it, you can either type in slido.com and then type in the number at the bottom to access the presentation, or you just take your camera and scan the QR code. It should bring you directly to the quiz. Okay, so I'm going to ask 3 questions just before I start in my presentation. As I said, I'd like to get to know all of you a little bit. It helps me to kind of calibrate for what people's backgrounds are. So my first question is, tell me a little bit about yourself. Are you a scientist, an artist, a student, whatever, however you'd like to describe yourself? And feel free to enter more than one answer here. So you're allowed to call yourself by multiple things. Okay. So I see we have at least one artist here, so I have to be on my best behavior. Okay, this is great. Actually, I'm fascinated by the things that people are adding, especially the Hawaiian hula dancer. This is awesome. Okay, so just to give you another minute to let people keep adding things in. I see that there's a lot of people who are identify as scientists and as students, and also a lot of people who identify as artists, and also pet owners, and someone who's sleepy. Okay, thank you so much. So I'm going to go on to the next question in the thing, just so that we get some perspective. So this is a talk about perceptions around scientists and artists, and so the question I have next is, what adjectives would you use to describe a scientist? And it could be of any kind of category. So just as a let you know, I have no idea what I was expecting from these answers. Although I am gratified that awkward and nerdy both show up. So at least we've described me fairly well. Okay. So while people just keep entering those, I'm going to move on to the next slide, which is, since I've asked you the question of how you would describe a scientist, and I see that the two biggest ones on this word cloud, and of course the size here represents the number of people who've responded with a specific one, are curious, creative, and smart. And then there's and apparently underpaid, which I'm not going to disagree with. So since we've talked about scientists, I'd like to ask the same question. So we're going to move on to the next slide, which is same question, but what adjectives would you use to describe an artist? All right, so definitely one of the things that jumps out at me is that creative is an important one both for the scientists and the artists. Underpaid is really figures prominently here, which I cannot disagree with in the slightest. Whatever I may think of any kind of artistic ambitions I may or may not have, I certainly am not going to be quitting my day job anytime soon. Okay. All right. So I think I'm gonna leave it there. I'm gonna actually save these, and I will perhaps reshare these in another context at some point. But I do appreciate all of you adding to all these insights, and I think that it's very helpful for us thinking about these things and the words that we use to describe scientists and artists, because that really is the central theme to tonight's talk is really asking, how big a difference is there between scientists and artists, and where's the overlap? And so Cynthia already said that my title is Unnatural Beauty, Art, Science, and Technology. And so just a little bit about myself. So Cynthia gave a broad overview. So I'm currently a professor and associate dean in the Faculty of Science. I did my BSc and PhD at Queen's University back in the 90s, although I didn't graduate the same year. I'm not sure why it says that. It's 97 I got my PhD. And the thing I want to point out with this listing of all my accomplishments is I'm somebody who's spent my entire adult life as a practicing scientist. So when I wake up in the morning, I think, okay, I'm going to go do science. I am a scientist. And of course, one of the ambitions as a scientist is that you publish in scientific journals, at least if you're an academic scientist, or if you don't get published in them, at least they'll talk about you in those, at least in a good way. And so about a month ago, there was an article that came out in the Proceedings of the National Academy of Science, which is a highly reputable journal and one that I've never published in, but I was pleased to find out that I was going to be discussed, or some of my work was going to be discussed there. I was a little bit disconcerted when I saw the article and realized that I wasn't being talked about as a scientist, but as apparently as an artist. And so this was an article on art and science, and a photograph that I had posted online of the drug isoniazid was incorporated into this article where they describe me as artist Vance Williams. And I've got to admit, this was really, I don't want to say upsetting exactly, but a little bit disconcerting. Like when you spend your entire adult life thinking of yourself as a scientist, and all of a sudden somebody's calling you an artist. I mean, one, it's just not how I view myself. It's not that I have any problem with artists, but I also feels really unearned because it's not like something I've been working towards. But more fundamentally, too, there's this idea that art and science are somehow at odds with each other, that there's a scission between them, and that you have art over here and science on the other side, and that there's this big gap. And this is really an idea that I think has been promoted, especially over the last 100 years or so. Now, that's interesting because when we look at the description, and both from your quiz, where basically both descriptions, when you had adjectives of what makes a good scientist and what makes a good artist, creative was really high in the list. And that's something that I think people outside of the sciences don't always realize, is that scientists really do privilege creativity as an important quality. I also find it really interesting that if you look at how people describe science, there's these two notable quotes, one by Pablo Picasso that says, "Every child is an artist. The problem is how to remain an artist once you grow up." And then Carl Sagan, writing several years later, said, "Every kid starts out as a natural born scientist, then we beat it out of them. A few trickle through the system with their wonder and enthusiasm for science intact." So you have these two famous, thoughtful people who were talking about artists and scientists, and basically saying that children are both natural artists and natural scientists, and that often they outgrow both of them. But it suggests that maybe there's this commonality between them that really we should contemplate a little bit. And this apparent divergence between art and science, even though there's a recognition of similarities, wasn't always the case. And so, of course, Leonardo da Vinci is the example that a lot of people think of with this fusion of art and science. So he was known not only for painting things like the Mona Lisa, but also for drawing the Vitruvian Man, which is shown here, which is, of course, an anatomical figure, and for doing a lot of designs and anatomy. And so, for example, his design of a helicopter is quite famous. Of course, you may say, well, Leonardo da Vinci lived in the Renaissance, which was a long time ago. He is literally a Renaissance man, probably the archetypical example, but that was a long time ago. So maybe science and art have gone their separate ways. And so, it's worth saying, well, what's happened since Leonardo's time? And so if you just jump forward a couple hundred years to Restoration England, we come across Robert Hooke, who was one of the foremost scientists in England of his time. He was roughly a contemporary of Isaac Newton. And one of the things that Robert Hooke is known for is publishing one of the first scientific bestsellers. In fact, some websites will refer to this as the first scientific bestseller ever, which is the short name is called Micrographia, but because people in that era couldn't just give a pithy title, they had to call it Micrographia, or some physiological descriptions of minute bodies made by magnifying glasses with observations and inquiries thereupon. So 1665, Robert Hooke started looking through a microscope at all the different kinds of things, and he made these absolutely gorgeous drawings. And so his book, which is very text heavy, is also filled with these amazing illustrations. And in fact, Robert Hooke trained as a child. He was actually apprenticed to an artist before he started on his scientific career. And arguably the reason why his book was such a bestseller was because it used these illustrations, these sketches that he got from looking under the microscope. By the way, I noticed there's a couple of questions in Q&A. Cynthia, did you want to ask them now, or are we gonna pause or just wait a bit?
I'll read the second one. Do you
Okay.
use AI for your art pieces?
No, I don't. Although I have for the work that I've done, I have used some mathematical programs. So one of the things I've done, and I haven't shown them in this. There's a really cool hyperbolic tiling program that basically applies a mathematical algorithm to repeat the patterns in a specific way. But no, I haven't really used AI. Like a lot of academics, I'm a little bit averse to AI. It's one of those things that academics are feeling a lot of anxiety about it. Plus, I honestly haven't had the time to learn how to use the technology. So I'm not saying I won't, but so far I haven't.
Thank you. I might as well read the first one because you mentioned
Sure.
some quotes. Someone said, this reminds me of the following quote: to see a child speaking with a tree is to see the child engaged in coming to know the connections of the universe and to feel empathy with another living entity. If you
That
want to
that
comment on that.
I think that's a beautiful quote. I would love to hear where that's from. It's actually an interesting thing. I'll get back to this later in the talk. But I think one of the things is that there are a lot of ways we can approach the world, and I'm talking about two um, apparent opposites today, although I don't think they are opposites of art and science. But I think that these other kinds of engagement of empathy with the world becomes very important when we talk, for example, about the interaction between, for example, Indigenous people and nature is very different from how Western societies engage, where, for example, empathy towards nature is actually a really important component that often is lost in Western cultures.
Right, that's it for now.
Okay, thanks, Cynthia. Okay, so Robert Hooke. So I mentioned he did these beautiful illustrations. I should also mention that he was also an architect, and so in the 1680s or 70s, London burned down, and they had to rebuild most of the city. And the architect Christopher Wren is credited with a lot of the work of rebuilding London, including building new St. Paul's Cathedral. Turns out that Robert Hooke was his assistant and had a hand in designing things like St. Paul's Cathedral, as well as the monument to the Great Fire of London. That's shown here on the right. This monument, Hooke apparently was the primary architect for this monument, which is hollow and actually is also a giant scientific instrument. So if you open the top of it, it acts as a zenith telescope. And in fact, even as late as 3 years ago, there were people doing scientific experiments in that monument. So Hooke was clearly somebody who was interested not just in science, but also in art and in architecture, which I think is very much at the interface of technology and art. I will say that my favorite quote from Micrographia is one where so he had these beautiful pictures of ice crystals that he saw under the microscope. Now, where he got these ice crystals was from puddles of urine that had frozen over. I think in Restoration England, there were probably London was not known to be the cleanest place, and so I think there were a lot of these puddles around. And so he basically scraped ice crystals off and looked at them under his microscope and did these sketches. The part I find really interesting about this is he also, in his text, says that tasting several clear pieces of this ice, I could not find any urinous taste in them, but the few I tasted seemed as insipid as water. So the good news is that Robert Hooke tasted some ice that was on top of a pond of urine, and it was just ice. That's an interesting organic chemistry effect. The bad news is he clearly knew what urine tasted like already, so that he could actually comment on whether the ice tasted like it or not. So this was actually something that was kind of typical for that era. They were quite experimental. Okay, so Robert Hooke was of course working in 1600s, where he didn't have access to a lot of technology. Now, if you go forward another couple of hundred years to the 1800s and the era of photography, which was just in its infancy, one of the first books, in fact, it possibly was the first book ever published that used photography for illustration, was published by Anna Atkins in 1843. And what she did was she applied this method called cyanotype, where you basically put an object on top of photographic film and you expose it to light. And where the object is, it doesn't change color, and where there's no object, it turns blue. And so she published this beautiful book on photographs of British algae that include all these illustrations. And as I said, this is credited as the first book that was published with photographic illustrations. If you're interested, you can actually visit the website. That's you either type it in or you use the QR code on the bottom right, and the book is actually really fascinating. It's mostly photographs. Okay, so far, the things I've talked about have been really limited to ideas where scientists have used art to illustrate their work, and this is something that we continue to do in the sciences. But in fact, there was a much more dynamic relationship between art and science. And so, for example, at the same time that Robert Hooke was tasting ice on urine ponds, an alchemist in Germany named Henning Brandt was taking big vats of urine and boiling them down. And the reason he was doing this was because he was an alchemist, and alchemists were looking for the Philosopher's Stone. Now, of course, we know Harry Potter, but the Philosopher's Stone was really supposed to give you either riches, so turning lead into gold, or giving you immortality. The alchemists believed that anything that was the color of gold must have the essence of gold in it. So they thought, well, urine is a great starting point for this. So he was just boiling these vats down. And in the process, he discovered the element phosphorus, which under certain circumstances, white phosphorus, which is highly, highly toxic, in fact, actually has this glow. And so 100 years later, the discovery of phosphorus was commemorated in this painting by Joseph Wright called "The Alchemist Discovers Phosphorus." So, and this is really meant to describe it. And it's a beautiful piece of art, I think, but also shows that, not only were the scientists using art, but the artists were paying attention to what was happening in the sciences and really responding to that in certain ways.
Vance, there's an interesting question in the Q&A
Sure.
box. So while you're on this slide talking about urine, what is with scientists' obsession with urine?
Well, I think it's partly a lack of maturity. We tend to be very scatological in our approach to the world. I think it's also it was a readily available starting material. For one thing, it did have kind of these mythic qualities. I mean, if you think about the alchemist, for example, thinking about the idea of transmutation and thinking about the fact that the body is apparently doing these semi-mystical transmutations on materials. We bring in food and drink, and it comes out our body the other end transformed. And so I think that probably was part of it. But yeah, so I titled this slide Eureka, and in fact, if I ever write a book, it will probably be about the chemical history of pee, because these two examples are not the only two examples. There's actually tons of them out there.
Interesting. Thank you.
Okay. I feel like I should make some comment about stream of consciousness, but we'll just move on. Okay. So let's talk a bit about something that's a bit more near and dear to my heart. So my area of research is organic materials. So I'm an organic chemist who studies materials properties. And my specific discipline originated from some work that was done in around 1888 by this guy here, Friedrich Greinitzer. He was a German, actually Austrian botanist, who was just analyzing molecules, and one of them was cholesterol benzoate, shown here. I think this is the only molecule that I've actually shown in the entire, sorry, one of two molecules in the entire talk. And he noticed something funny, which was that when you melted this compound, usually when crystals melt, they start solid and then they just go to a liquid. When he melted it, it first melted not to a clear liquid, but to kind of a cloudy liquid. And if you want to get a sense of what something like this would look like, this is kind of an idea. So this is a vial of a material similar to what he was studying. This particular one at room temperature is a cloudy liquid, and it kind of looks kind of like almost like I took some snot and put it into a vial. Moving from one bodily fluid to another. So this observation by Reinitzer was the discovery of a whole new class of materials, which for our purposes, the material actually found the first application was found for it was about 80 years later in mood rings. So this material he discovered actually changes color as you heat it up. So what he didn't understand at the time was what his material was. We now refer to these materials as liquid crystals. And this is just a picture on the right of holding up a vial. Now, because Reinitzer didn't really know what this material was made up of, it was unexplored territory, he passed it over to a physicist named Otto Lehmann. Lehmann happened to be a microscopist who had the only example in the world at the time of a microscope that was fit with polarizers, so like kind of the lenses you see in polarized sunglasses, as well as the ability to heat samples up, which were really important for studying these materials. And so Lehmann picked up this cause of looking at these materials, and he spent basically the rest of his career examining them, and he made these amazing sketches of different kinds of things. And this is an amazing thing to do, is to look through the microscope and be able to draw these materials, which, as we'll see in a second, are actually very dynamic. And so he came to understand that these were unusual materials that were liquids, but they were not behaving like normal liquids. And so if you were to take his technique, which is polarized microscopy, it turns out that this technique that was first applied to liquid crystals back in the 19th century continues to be the major method that is employed in the analysis of these materials. So it's a good example of the right technique at the right time. And so this is an image that I took in my lab of one of these liquid crystals, not quite the ones that Lehmann was looking at, but this is actually a movie, and just to give you a sense of how dynamic these materials are. So if you watch these materials over time, they move, they change colors, and so there's almost a living quality to them. And so these can be very mesmerizing materials. And in fact, this is something that I started working on liquid crystals in the early 1990s, and I've never stopped being captivated by them. And what's rewarding is, as I said, if you're in my area, you are actually taking photographs of these kind of materials, and it's not just you're taking pictures because they're pretty. The pictures tell you something about the way the materials are organized. And I'm not going to talk about how you get that information here, but just to get a sense that these three pictures, for example, that I've shown here, are very information-rich images that I use as part of my scientific analysis. So these are not designed as art; they are designed as scientific experiments. But people would periodically tell me, they'd look at it and go, "Wow, that's really pretty. You should do something with that. Maybe you should make a calendar." And I was always reluctant to do that until the era of social media, where I decided, I really should start putting these out here. And honestly, I was motivated in large part just to try to recruit people into my research lab by saying, "Hey, look, this is the kind of work we do. Come join our lab." And so I'd start posting videos on YouTube, and I'd use Instagram and Threads and Blue Sky more recently, and Twitter for a long time, and I suspect for not much longer. And so I would share these pictures, and it was really just kind of like a, hey, look at us, and as a way to maybe introduce ourselves to a broader audience, and really originally intended as a way to kind of engage other scientists who might be interested in talking about our work. And the idea with these materials is really that this is referred to as in some streams as portal images that are basically images that were in the front pieces of old manuscripts, which were basically art that was meant to draw people in. And we still use variations on this. We don't have front pieces on books anymore, but we do have covers of journals, and we have graphical abstracts. So in the course of posting some of these images, I got a really interesting email one day from a curator from BAMFA, which is the Berkeley Art Museum and Pacific Film Archive. And they were putting on a show called The Architecture of Life that was featuring, among other things, some of the original sketches that Otto Lehmann had done. And so he said, hey, so we don't know what these sketches are all about. We have these pictures, but can you help us? Can you be basically a consultant? And so he and I had this very fruitful back and forth, and I shared some images and said, okay, yes, this particular image is a smectic crystal, and these other ones were other kinds, and I would show videos to him so he had comparison. And eventually, and this was something that was really rewarding and surprising for me, is that he said, we'd actually like to put some of these images next to Otto Lehmann's in the art show. So this was actually my first encounter with the art world in any formal way. So this is the cover for the book that came out of this exhibit, and in fact, the front page or the second page of it is actually one of my photographic images. So it was interesting, and it also showed that people were very interested in engaging with science and art as something that we're in conversation. Cynthia, I see is there another question there?
Yes, while you're speaking about your social media, someone's asking, have you recruited grad students or connected with other scientists through your social media? Is social media effective as a means for engagement, and would you recommend it?
I would. I don't know if I've actually ever recruited a grad student, which was my original intent, but I have actually several collaborations that have grown out of that. And in fact, there have been a lot of opportunities that have come up. And so right now I'm in the middle of writing a grant to start a formal collaboration with somebody who had reached out via Twitter saying, hey, how do you do this technique? And so basically we're going to have a collaboration where we have some knowledge sharing. They teach us how to do some of their chemistry, and we teach them how to do the liquid crystal analysis. So there has been definitely some engagement that way. But what I think, and one of the things I'll talk about, is that what's really rewarding is that the intended audience was by and large actually much broader. Like what the actual audience was actually much broader than what I initially hoped it would be, and it would be more of the general public. But yes, it is something, but I would say that it's a lot of work. You have to kind of maintain a presence and do a lot of work to keep your face, as it were, out there.
Thank you for that question.
Okay, so speaking of which, so the idea of using images as either as outreach or just sort of to share the beauty of your research, this is not something that's novel to me by any stretch of the imagination. So as an example, for the last 50 years or so, Nikon has run this contest called the Nikon Small World contest. With the on the left, I've got the picture of the 2022 winner, which is just gorgeous. But interestingly, if you go back to 1975 to the original winner, they used the same technique that I use, which is polarized optical microscopy. And in this case, they were using oxalic acid, which, by the way, is isolated from urine, just in case anyone wonders. So for me, as I started to think about making that transition from talking to my colleagues to talking to maybe the broader public, I was kind of getting bored, not with the images. I will never get bored of liquid crystal images, but I was kind of getting bored of every time I'd post a picture, I'd say, oh, and hey, this is the kind of material you'd find in an LCD, or this is the kind of material you'd find in a mood ring. And so I started to think about how to expand out kind of the scope of what I was talking about to things that weren't just liquid crystals, but other kinds of organic materials and things that maybe people had heard about previously. Uh, and and one of the things that really motivated me as I thought about how to kind of use images as a science communication tool is reflecting on the fact that scientists are very wordy people. We have developed a language, and each discipline has created a very specific language. So, for example, just in the narrow field of liquid crystals, there are all these terms. So this is just a listing, not a complete list, but a listing of common flavors or types of liquid crystals. And I think with one exception, I've worked with all of these before, and there's actually many more. So that's just the kinds of liquid crystals that we have to worry about, and we have names for each one of them. And of course, if you don't know, it just looks like a bunch of nonsense words. And of course, on top of all that, there's a bunch of other terms, and these are just a few examples that we use within the liquid crystal field to refer to different kinds of effects we're interested. And on top of that, I'm also an organic chemist, so we also have all these other words that we use to describe different kinds of concepts. And so all sciences are their own languages, their own dialects, and this is intimidating. If we try to communicate to people who are not scientists, or even talk about the scientists who are not in our discipline, this type of language barrier is very real, and it keeps people kind of at arm's length, or maybe makes them run away. And so my feeling was, can we engage people in maybe a nonverbal way, at least initially, get people engaged enough that maybe they'd be willing to talk about science and maybe learn some of these terms. And so that's when I started to post pictures. And so this is where I started to change my approach. So I was no longer taking pictures for this purpose of scientific analysis. I started to take pictures because I thought they had an aesthetic quality which was somehow engaging. And so this is citric acid. Lots of people have heard of citric acid if you're a biochemist. There's the citric acid cycle. If you're just a person in society at large, citric acid, of course, shows up in all kinds of fruits, as well as it's added to a lot of foods to make things taste sour. And you could also say, well, here's a microscopy image of aspirin viewed by polarized microscopy. And it sometimes you get these patterns that emerge and you have no idea where they're coming from, and they're complicated. But for me, they were beautiful, so I thought I'd share them. And so that's what I started to do. And in fact, it kind of took over my social media feed. And just as another example, and just to show that you can present pictures that are, hey, look pretty, and you may have heard of the molecule, but you can also say, well, here's a material which you may not have heard of. This is potassium nitrate, otherwise known as saltpeter. This is a material that historically is really important because it was used in explosives, as well as in fertilizers. And so it gave, this is where there's kind of that almost Trojan horse, where here's the picture, it's pretty, maybe someone will say, tell me more, and having some stories to back it up. The one that I quite like, partly because the crystals were, again, really unexpectedly pretty, were this compound, which doesn't sound familiar probably to anyone, 2,3-dihydroxybenzoic acid. Its claim to fame is that it is a molecule that the pine beetle, the bacteria that lives in the mouth of the pine beetle, uses to bind to iron. That's called the siderophore. And as it happens, when that siderophore reacts with iron, it creates a blue pigment. And that's actually when you see trees that have been killed by pine beetles, they will often have this bluish tinge to them, which is known as denim pine. It actually was in quite high demand a few years ago. And so again, the image gives an opportunity to actually unpack a whole lot of what I think is really interesting science. Okay, now having said that, so far the pictures I've been showing have been pretty much what you might classify as abstract art. You know, they are real materials, but the pictures may not mean anything. But the one thing we should be aware of when we start talking about images that have some scientific meaning, whether they're data or things that we have constructed as part of a diagram, is that we have layers of meaning that we as scientists may assign to the picture that the general public may completely miss. So, for example, here's a picture that I think even if you're not a biochemist, you might recognize it as DNA. So, of course, it has that double helical structure that is so famous. Now, this is not the prettiest version of DNA that you'll see out on the web. In fact, most people might argue, if you're not a scientist, that it's kind of ugly. Because it's got lots of colors going on, and it's a little bit cluttered. But if you're a chemist like me, you look at this and go, wow, this has got so much information. Embodied in this picture is the secret of life, because if you understand base pairing, you understand how DNA makes copies of itself. And if you're a chemist, the colors here have meaning as well. So the little gray balls represent carbon, the bluish purple ones represent nitrogen, the red by convention represent oxygen, and so on. So you look at this, and as a scientist, you go, oh, there's a lot to understand here. And there's a lot of stuff here that isn't real. It's just a fiction that is convenient for representation. So, for example, we draw molecules as balls attached with sticks. There's no sticks in molecules. They're not attached to each other by that. It's a lot more subtle and complicated, but it for us is a simplifying representation that is quite valuable. So this image, I would argue, this could be regarded as art, but realizing that a non-scientist looking at this image is going to take away a very different take-home message. I'd blown this up. Than a scientist would. Right now, this is not unique to science. In fact, if you look in art, art also is a form of visual language where meaning is conveyed through different kinds of images. So, for example, this is a famous painting by Raphael called Madonna del Prato, which I believe means Madonna in the harbor. Now, this is a picture that if you were living in Raphael's time, so in the Renaissance, you would immediately get a lot of information out of this, which a modern viewer, especially one who's not from a Western culture, would totally miss. So first of all, the colors here are actually significant. So the woman in the picture is the Virgin Mary. And the way that we know this is the Virgin Mary is that she is dressed in red and blue. And so the convention isn't that red is oxygen and blue is nitrogen in this case. It's that this represents this specific person. The fact that we have in this image this kind of triangle that isn't apparent till you draw the triangle around it, was symbolic for at the time that the church was meant to represent stability, and a triangle was a representation of stability. So there's these very subtle cues in here. And in fact, this was right around the time of the Black Death. And so the signal from this picture was that the church was, even though they were tumultuous times, that the church would be providing stability. And of course, there's other parts in here that most of this picture looks kind of real, except for maybe the precociousness of the two children. So the kid on the right is meant to be Jesus. You can tell he's got a halo that's quite bright. The kid on the left kneeling and holding a cross is supposed to be John the Baptist, and also has a halo. And of course, like our bonds being sticks, these aren't real. They are just meant to signal information about what's going on. Okay, so I bring up this picture just because it shows that images have a lot of meaning, and it also means we have to be kind of careful when we present them. So here's a picture, or here's a movie that I posted quite a few years ago, so back in 2017, and this is an image of a what's known as a cholesteric crystal, uh, and this image had more reaction than anything that I've ever posted. I think it had something like 800,000 views, and it's interesting because the views were ranged across a whole gamut. One is that people said, "Is this alive? Is this a living creature of some kind, or a bunch of living creatures?" And so you got to have these conversations about, no, this is actually just a simple organic molecule that's behaving in a specific way because of air currents and phase transitions. But actually the question of what's life and what isn't life is fascinating. And so it did lead to some really interesting conversations. What I found most interesting, though, is that the comments on this video, so this was posted on Instagram, weren't actually all that positive, even though this was hands down the most engaged upon picture or movie I'd ever posted. So some of the comments were things like, "This is nasty. It made me itch. It makes me feel so sick." So there's people were reacting, and I look at this and go, "Oh, this is obviously a liquid crystal doing these very different things and interesting." People were having very visceral reactions to this, and I think it was tied to the fact that it reminded them of maybe worms or bugs just crawling all over the place. But the interesting lesson, I think, too, is just because people find it uncomfortable doesn't mean that it's not effective as a form of engagement. So it ain't pretty, at least according to a lot of these viewers, but they were responding to it and they were engaging. And that is a lesson from art, right? So a lot of very effective art in the 20th and 21st century were pieces of art that were deeply uncomfortable for the viewers, and those are the ones that sometimes get remembered. So make of that what you will. All right. Now, one of the things that does come out of that is that clearly I'm not qualified to try to guess how people are going to respond visually to something, because I'm a scientist. I'm not an artist. I'm not a professional at visual communicator. So if you want to communicate professionally, go to the artists. And so I've been very fortunate to have some really good collaborations over the years. One of the first was Natalie Lavoie, who was at the time doing her Master's of Fine Art at Emily Carr. She came to me and she said, "I had this idea for visualizing saltwater and freshwater and how they come together, and can I do some art to represent that?" And so she spent a few days in my lab and we chatted through a lot of different techniques and ways in which to photograph materials. And so that work actually ended up on as part of the TransLinks, both on their inside their buses on little panels, but also there was a bus stop, I believe, in Marple that had it was actually had a film of some of her images on it. So that was really cool. So I was not an artist on that, but I was kind of the consulting scientist, and so that was really useful, and it shows that it's a two-way street. Science can be a servant of art as much as art can, for example, be a servant of science. Now, of course, the ideal, I think, is the collaboration where scientists and artists are working together. And so again, this was driven by an artist, but I was approached by Richie Carey, who is a Scottish audio artist. So he makes music, and he had this idea for taking the videos, and unfortunately I couldn't get the audio to work here. But what he did was he said, "I wanted to basically, I'm going to show the videos to these students who are all basically grade 2 students, inner city Glasgow, and I'm going to have them do interpretive dances to the videos. So basically, they are going to physically respond to what they're seeing under the microscope." And then I'm going to film them, and then we're going to put it to music, and then we're going to have an art installation, which ended up in the Glasgow tramway station, which is basically an old tramway stop that had been converted into this pop-up art gallery. And so this is this picture, that this is the video that he created of this. And really, until you've had a bunch of 7-year-olds do an interpretive dance to your research, I don't think you've really accomplished what you need to accomplish in life. So this was something that was a huge kick for me, and something my goal is to someday visit Glasgow and actually at least visit Richie, because we've never met in person. All right, finally, so I'm going to wrap up here, and I know I've been talking for quite some time. I want to mention too that so I've talked about art in service of science, and I've talked about science in service of art, and I've talked about collaborations between art and science, and I've also talked about art inspired by science. But I want to circle back to where I started, which is as a scientist. I've kind of made this transition, at least in part of my life, where I don't just spend my time looking at materials as a scientist, but looking at them artistically. But of course, you can't shut off that other side of your brain. And so one of the things that has happened is that I've basically done a lot of experiments, art experiments, with the microscope, that have effectively turned into a little bit of scientific experiments where you make observations and go, something really interesting there. And so this is actually has had a really positive impact on my research career as well. That I have several research projects that have arisen from observations that I got from looking under the microscope. And so this image here, which is showing crystals freezing from the melt, was actually one that was an inspiration, because it turns out that growing nice crystals from the melt requires a lot of careful control of conditions, which, as it happened, because I have enough scientific background to understand what the parameters that I'm changing are actually doing at the materials level, it has this feedback loop. It's like, oh, wait, I could use this when I'm trying to design new materials. If I want to grow crystals of a specific type, which turns out to be an important scientific problem. So this has been an interesting journey from my perspective, because I've learned a lot about not only art, but also about science. Okay, so I just want to wrap up with a few kind of comments. One is as I said, there's a lot of ways in which science and art interact. And I think that there's more overlap between science and artists than people suspect. I think the quiz that we did at the beginning, really, or the poll, really brings it home that creativity is one of the central themes for both artists and scientists. And so there's this naughty interconnectedness between art and science. They're not, they're highly divergent. They're not far apart. A lot of scientists also do art. And I think that a lot of artists are very interested in science and would like to work with scientists. So just like menthol, which is the molecule that gives you mint flavor, has these very intertwined crystals. There's all these different connections. Science as accidental art, which is where I started, moving to a form of science communication, and intentional art. So basically making images for the sake of their aesthetics and for other kinds of value. Their inspiration for art, the collaboration between the two, and then finally art as an inspiration for science. All right. So just want to conclude with a couple things. One is one of the people who really has led to this idea that science and art are highly divergent in our culture was C.P. Snow, who wrote this book called The Two Cultures. One of the things he said is the division our culture is making is us more obtuse than we need to be. With good fortune, we can educate a large proportion of our better minds so that they are not ignorant of the imaginative experience, but both in the arts and in science. So he focused on the imagination, the creativity as well. What he argued was that maybe there's a phobia between the two fields where they don't recognize that common cause, that common way of seeing things. And so I don't think we should, I think we should be mindful of that and try to build more connections. And I want to wrap up my comments, and plenty of time for questions and discussion. But you'll notice that my talk was very Eurocentric, and I apologize for that. It's just very easy to come up with lots of European examples because a lot of the history was written from the perspective, from a very Western perspective on both art history and science. But that's not to say that the comments that I've made here can't apply more broadly. So if we can talk about the connections between art and science within Western culture, we can also talk about the connections between science and non-Western cultures and viewpoints and perspectives. And somebody already brought up that beautiful imagery of the tree and empathy between humans and the natural world. And so there's this concept known as two-eyed seeing, which is brought up a lot in discussing how we can bridge the divide between Western viewpoints and Indigenous viewpoints, which that doesn't privilege one over the other, but says, look, these are different ways of seeing the world. And ideally, what we do is we learn to see through both the Indigenous way of seeing as well as the Western way of seeing. And so I think that in microcosm, talking about science, which is often held up, I think, as the pinnacle of Western achievement, it can be thought of as if we can learn to really look at science and be enriched by looking at science through other kinds of viewpoints, then we are going to be better as scientists, but we're also going to be better as communicators, and we're going to bring more people in and engage them and also enrich our own worldviews. So that with that, I want to thank all of you, and as was acknowledged at the beginning, I do want to acknowledge that we are on the traditional unceded territory of the Coast Salish people, which I've got a longer list here just because it includes all of the SFU campuses. But I want to thank all of you for your attention. And I also want to, I should acknowledge I am a fraud. I am not an art historian, but my wife is, so she coached me on some of the art history stuff. But thank you for your kind attention, and feel free to reach out to me on social media or just send me an email. I'm happy to chat further about any of these things.
Thank you. Thank you so much, Vance. That was an awesome presentation, and I personally love the last slide where you talk about two-eyed seeing. So thank you so much. So at this time, I invite people in the attendee room, type in your questions or comments or whatever messages you have for Vance, and I will try my best to read everyone's comments and questions. I will go on to the first one I see that I had left off earlier. Would you take grad students interested in doing science and art-related research? Would that be acceptable in terms of academic standards for grad programs at your department?
Absolutely. I mean, so I think that there's, I mean, so I think and speaking so my other role is the Associate Dean of Grad Studies for the Faculty of Science. So I think I can pull some strings. No, seriously. The thing that I think is, the university offers lots of pathways to learning. And so even though a student may not be fit comfortably within the normal confines of a chemistry degree and may not have the background, there are other departments and other ways in which the faculty of chemistry can help students. So yes, absolutely. In fact, I have a project that I very much want a grad student on to do with art. So yes, reach out to me. I think it would be fascinating.
Thank you. Excellent. Next question. Have you ever used those parallels and approximations between science and art in your higher ed teaching or in a teaching learning situation? If so, how was that?
To think about this a little bit, so I think that the parallels between science and art, it's sometimes hard for me to point to a specific example. But I do think that what has happened over the years, so I've been doing this kind of science communication over the last 10 years or so, in various forms. It's really changed the way in which my perspectives on learning have been. I've learned as a teacher to talk less, ironically, given I've just talked for the last hour. But like learning that you have to find ways to engage people. I think it's taught me a lot of humility with respect to the knowledge sets that people come to and bring to the table, and how enriching their perspectives are. So I will share that that several years ago I ran a course that was outside of the chemistry. It was actually in the faculty environment on environmental controversies, where it was amazing because very few of the students were science students. But conversations you could have as people bring in these multiple perspectives was incredibly rewarding. So yeah, so I guess it's kind of known that I haven't explicitly explored this idea, but there's some people who have. For example, I have a colleague at Western University in Ontario who had people do art assignments as part of theirs, like, show me your conception of this kind of chemistry, and just had people do artistic impressions. I've encouraged students to document things through social media. I had a not very successful experiment with my class about a week ago on dyeing indigo in class. It was a lot smellier than I anticipated, but it's experimental.
Mm-hmm. Mm-hmm. I will go back to one slide you showed on crystals freezing, and you were explaining earlier how this can be used to design new materials. Can you give us a bit of an explanation of the reasons behind the colors? What makes something yellow or blue or orange?
Sure. Maybe I'll just share the screen again and go back to that. So was it this one that we're talking about, maybe?
Yes.
Okay. All right. So with this, the fascinating thing with this technique, polarized optical microscopy, is that the material that we're looking at in the microscope, if it wasn't under the microscope, it would just be white crystals. So it doesn't actually look that interesting. And so the colors that arise have nothing to do with light being absorbed by the material. And so usually things are colored because, one wavelength of light gets absorbed, another one doesn't, and we see the ones that aren't absorbed. In the case of this technique, what happens is there's an analogy, and I apologize to the physicists in the crowd if there are any. It's an imperfect analogy, but if you think about the colors we get, if you just have a little film of oil on wet pavement, we were all familiar with what happens, when it rains up here or it rains in the Lower Mainland. If you look at the street, see those kind of beautiful oil streak patterns that are kind of rainbow pattern on the pavement. There's some similarities there in terms of the optics, where you get certain kinds of colors that emerge from basically two colorless materials and the way light interacts and interferes with itself. So it's basically, some people will describe it as an interference pattern. It's a little bit more complicated than that, but it's again, it's not, the colors that we're seeing are not intrinsic to the material. It has to do with the way in which we use the technique, and it has to do with the fact that we have these polarizers. So, this picture here on the lower right is basically this material here in this vial. So the stuff that looks in ordinary light as kind of like this cloudy fluid with no colors develops these beautiful ranges of colors under the microscope. And it has to do with a whole variety of things. It has to do with the orientation of the molecules. It has to do with the thickness of the sample, and it's very complicated. my poor students in my fourth year class are about to get a very long section of my course dedicated to the optics of liquid crystals. So they'll be able to tell you in gory detail, but it'll take me about 3 weeks to get through for them.
So someone just asked, and it's related probably to this one you're showing now, is this natural color?
It is natural in the sense that I haven't done anything.
Okay.
So basically, you set up the microscope. There's two polarizers, one below, one above, and the colors that you get from that are emerge from those interactions of the polarizers, the light, and the sample. So I haven't gone into this sample and said, oh, this part's going to be purple, this part's going to be yellow, which is commonly done in a lot of techniques like electron microscopy, where you will see false color images. And it's a really interesting discussion too about approach to changing the appearance of an image. If you're in the sciences, how you deal with your images is something you have to be really careful and scrupulous about. You don't want to misrepresent information by modifying the image, but you can modify the image to some extent as long as you're being kind of clear about why you're doing it and what you're doing. When you're doing something for artistic purposes, all bets are off. So you can modify things, and I have done some false color images, and I've done things of that type over the years just to get an aesthetic sense. And so one of the questions right at the beginning was, have I ever used AI? And I mentioned using hyperbolic tiling to get new images. There's no reason to do that scientifically, and it is a mathematical manipulation of data. I feel fine with that because I'm not doing science in that point. I'm doing art.
So while we're speaking about colors, I might as well refer back to another slide you had where you showed denim pine. And we'd like to know what makes that pine that has been infested by beetles turn blue, and who comes up with these names, denim pine?
Well, so the denim pine was because it looked kind of like the blue of indigo dyed jeans. So that's the name. I have some here. It doesn't look, and you can't really. It kind of looks grayish green. It doesn't come across here very well. Maybe if I change the lighting a bit. No. Here, I mean, in person, it looks kind of greenish. It often will look more blue. In terms of the color, is fascinating because what happens is neither the iron nor the dihydroxybenzoic acid have this color, but when they come into contact, they form this complex, which together they form this blue color, and it's one of these underappreciated areas of science. That has one of my colleagues, Tim Storer, actually does a lot of work on these kind of complexes known as non-innocent ligands.
Interesting. Next question. Thank you for sharing your work. Just wanted to ask if you have any other recommendations on people who, like yourself, are involved in communicating science through art or vice versa.
Well, I think that one of the things that there are communities out there, and there are people who are very interested in engaging in kind of like-minded, and I mean, I think that there was great attendance tonight. I appreciate all of you showing up. So if you are an artist who wants to engage with scientists, one of the things is despite the fact that we are on a mountain and feel like maybe we're like kind of inaccessible, in fact, most of us are quite interested in talking. And so, talking about, like, there are lots of people who would be quite happy to, engage with artists and come in. I think that I was fortunate in some of my interactions, partly because social media was an avenue for reaching that broader audience. And I've had some interesting requests over the years from artists. Number of people wanted to use my images for album covers. I didn't even know album covers were still a thing. The but also, I mean, so for example, Natalie Lavoie, that collaboration arose because my wife's an art historian, so I got to meet with them. But you know, my dream is eventually that the Faculty of Science here at SFU would have an artist in residence program. So if any of you in the audience are rich donors and would like to endow an artist in residence program, please reach out. But yeah, so I don't know if that answers the question. I think that's something that it's not always easy. I think I mean, again, these I've highlighted some opportunities that have come my way, and I've been very fortunate at that. But it's you don't always understand how these opportunities come about. But I think that it is a lot of work. You do have to work at it to cultivate the relationships. But there are groups that are there are a lot of collectives out there too. Like there are programs that are specifically aimed at art science collaborations, and some groups. There are fellowships. If you can look up artists in residence um, uh, uh, for different scientific institutions, and there are a fair number out there.
Mhm. Now, because you're just speaking about programs, I'm going to ask this question on behalf of the high school students who might be in the call tonight. Any recommendations or tips to share for high school students thinking of taking something in science as it relates to art? Is there any program that you would recommend or suggest?
Well, it's interesting. I think that I think that that often there are few programs that are specifically about um, art and science at a lot of universities. They exist, and I think that there are opportunities. Um, I think that the wonderful thing about SFU is it's one of these places where people can collide quite naturally with colleagues, and they can choose their own adventure to some extent.
Right.
And so there are opportunities if you are a science student to pursue a more artistic side. You know, like we have this great space where Cynthia works called Sci-Space, where it's a coming together place for the science undergrads. And in that room, we have all these great photographs and other images of science art that have been made by various people from all the faculties. And so there's a lot of this going on. I think that there's, I think, a willingness to look at science and say, you know, this can be beautiful. There's no reason to be embarrassed by sharing your love of the beauty. And I mean, the other side too is you know, if you're an art student, there are courses out there that are accessible to, you know, we have breadth courses at SFU, which are meant to be science courses that are more accessible. And you can talk to scientists and ask and see if there's ways in which you can engage. And I think it's going to be really important. Well, I think science desperately needs artists who want to talk about the challenges of our society, which I think, quite frankly, artists do a better job talking about societal challenges than scientists do, because we get caught up in our words and our technicalities, whereas artists are trying to comment in a much more visceral way. So I think, you know, I think we need to find better ways to break down the barriers. Fortunately, I can't point to a specific program at SFU to pursue, but there are certainly, we've got some great communications programs, and the Faculty of Science is a very vibrant place.
Mhm. So speaking of interdisciplinary work and program collaborations, there's a question here asking if you have any tips on how best to approach scientists for potential artistic collaborations.
Uh, well, I'm going to throw Cynthia under the bus here. I'd say contact her, and she may actually know the people to contact. Um, you know, it's certainly, you're welcome to contact me at SFU if you're interested as well, because one of the benefits of being an administrator is I've gotten to know a lot of people across the university. So I may not be the best person to help if you've got something in mind, but you know, I'm happy to maybe help make those connections. Like I said, it's really a willingness to reach out, a willingness to say, this person, usually the worst that happens is you don't hear back from the person.
Right.
Often people will say, hey, that's really cool. Maybe I can't help you, but maybe I know somebody who
Yep.
can, and create that relationship.
Yep. And since you mentioned that, I might still mention my email address. It's posted on the website anyway. So if you want to make that connection, just send me an email, SFU Science Outreach at sfu.ca. SFU Science Outreach at sfu.ca. The next one is more of a comment, not a question, but you're open to commenting on this, relating to your mention of two-eyed seeing. The book Braiding Sweetgrass is specifically about integrating indigenous knowledge with scientific methods as a way to complement it, mainly focusing on botany. This was an excellent talk. Thank you. So you have any comments on that book on two-eyed seeing?
Absolutely. Yeah, I think Braiding Sweetgrass is one of the most important books I've ever read, as a scientist and as an educator. So it's interesting that for years I used that example of Robert Hooke and the urine and ice crystals as an example of the fact that when a liquid freezes, the ice comes off pure, leaving behind everything else. In Braiding Sweetgrass, she talks about how that exact same method that was used among traditional people to purify maple syrup. So they would make deep troughs of maple syrup, let them freeze overnight, pull off the ice that was just water, throw that away, and what they were left with was stronger maple syrup. And so it was actually a way to harness the natural temperature cycles at that time of year without having to boil a lot of liquid off and use a lot of fuel. So this brilliant idea of like an energy efficient way of purifying or enriching or refining maple syrup using this same physical method, which in my previous kind of presentation, I would always say, hey, well, look what this brilliant thing Robert Hooke found. But in fact, what he really found in a much grosser way was something that was well known among traditional cultures, that you can basically purify a material by freezing it and getting rid of the ice and leaving behind the stuff that you wanted.
Thank you. Excellent. There are other comments all thanking you for a fabulous presentation tonight, but I'll end with this last question, and I found it very interesting. Thinking about creative collaborations, are you thinking just visual arts, or would you also consider music? You did mention interpretive dancing by the kids earlier.
No, I mean, I think this is the thing that is like, you can get in trouble by defining art too narrowly, and it's very easy, especially if you're somebody like me who's visually oriented, to say, well, here's the parallels between my visual images and visual art. But I think that absolutely the idea of the music, and there's lots of ways you could sort of think about this. So, as an example, the lot of the patterns in those movies that you saw had arose because you had a material where the temperature was changing just because the air currents nearby, and so things would kind of pulse or react to people opening doors or breathing nearby, and so you could think about ways in which music could actually be coupled to the images you see, or talking about I mean, there's a whole range of things. And not being a musical person myself, I know how to play the radio, and that's about it. Is that I don't? My imagination is constrained, but I think that there's lots of ways in which music, poetry, visual arts, you name it. There's so many ways in which we could bridge between art and science.
After all, there's so many other forms of art.
Yes.
All right. So thank you so much, Vance, for this presentation tonight. I really appreciate your being with us. And I'd like to thank all those who joined us tonight. Thank you so much. And I hope to see you again. The next event is happening on the 24th of October. and we have someone from our mathematics faculty. So I hope you join us then. Again, thank you so much, Vance.
Thank you.
And good night, everyone, and take care. Hope to see you in October. Bye for now.